Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about LEDO question number 1047. Remove all adjacent duplicates in string. You are given a string S consisting of lowercase English letters. A duplicate removal consists of choosing two adjacent and equal letters and removing them. Okay, we repeatedly make duplicate removals on S until we no longer can. Okay, fine. Return the final string after all such duplicate removals have been made. It can be proven that the answer is unique. Fine. So we want to remove the adjacent duplicates. Okay. Fine. In this series, in this playlist, we will see like 4 questions like this model. Okay. This model have two patterns and we can see those two patterns in this example. First, we can see what this example states. See here, if this is the example, A, B, B, A, C, A. Now, just say me whether I can remove this BB. Yes. Why? Because B and B are adjacent and they are equal. So I will remove it. Okay. Now what is my string? A, C, A. Now this A are equal. So I can remove it. Yes, remove it. So what is my answer? CA. So CA is my output. Fine. Understand? Now take this example. AZ, XX, ZY. This can be removed, right? This XX can be removed. So A, Z, Z, Y. Other again, this ZZ can be removed. So that A, Y. So A, Y is my answer. Yes, yes. Now, how can I do it? Just observe the immediate next character is removed, right? Immediate next character is removed. Again, this character and this character is removed. So the last character that is inserted, this last character is compared with the first character when we split this string, right? So that why can't we use this tag? Last in first out, right? Last in first out. So that why can we use this tag? Okay, come up with me so that it will be more clear. Just observe carefully. If I take this string, first place A, again place B. No, B. Should I place B? No, no. There is adjacent characters, right? So I want to pop out. I want to pop out. Now again A. Yes, A. But what is the top of this tag? It is A. So should I place that A here? No, no. Just pop it out. Just pop it out. Now go to this C. Just place C. Now A. Whether C is equal to A? No. So place A. Now what is our answer? If we reverse that stack, okay, CA is my answer. That's all. That's all about this approach. Okay, this is the first approach. Now, tell me about the time complexity and space complexity. What's the time complexity? I can say time complexity is O of n because we are placing each and every element inside a stack, that is n, and again we are traversing to each and every element in the array. So that in worst case it takes up to what? O of n. That's all. That's all. And what is space? It is also O of n because we are using an auxiliary space. That's it. Okay. So can we optimize it? Just observe carefully. The second approach is two-pointer approach. What? Two-pointer approach. Very, very important approach. Okay. If you don't know about anything about two pointers, just go back to my two-pointer playlist. Just watch 1 or 2 videos so that it will be more clear. Just watch the forward pointer video. Okay. So that's the second part of my playlist. Fine. I will give that playlist in my description. Fine. Now, just observe this approach. This approach can be used in a language where string is mutable. String is what? Mutable. Only in the language string is mutable. This is so important. In Python, we cannot use this approach. In Python, we cannot use this approach. In C++, Java, or C, these type of languages, we can use this approach. Okay. So just observe this carefully. It will be more efficient. Okay. Just see here. If I take the same example. Now, just observe carefully. This is my example, okay? This is my example, and this is the index, and f is equal to 0, and I is equal to 0. Fine, fine. Now, initially, this is our setup. Now, just observe carefully. This is the condition. What's the condition? S of f minus 1 is equal to s of I. So, this is the important condition we will write in this approach. Just come up with me, okay? so that you will understand why we are using this approach. Fine. Now just observe s of f minus 1 is equal to s of I. See here, it means f is 0 already. Then how can be its previous element is present? Okay, so there is no previous element. So just move to the next element. Just move to the next element. So we are moving to the next element. So I will be here, and where will be my f? F is also where? At this point. Yes, yes. Now update. F is what? 1, and I is what? 1. Now again, f minus 1 is 0. So a, whether a is equal to b? No, it is not equal to. So don't worry, just move ahead. Move ahead by placing what? By placing this b here itself. I will tell you why we are placing b here itself. Okay, we will do what? If this is not a condition, if this is not a condition, else, okay, this is not a condition, then we will do what? We will shift I to f position. Okay, I will say why we are doing this. Now we are shifting here, right? Again we are shifting I where? I to the next point, I to here. Now my f is 2, I is what? 2. Now here is our logic works. Wait, see here, f minus 1. F minus 1 means what? B. B is equal to s of I is also b. So b is equal to b. So this condition is satisfied, right? So I want to take this. It cannot be a part of my answer. So I will do what? I will shift this f pointer, this pointer here, minus 1. I will do f minus 1. So what is my f value now? It is 1. But our I pointer will be moved as it is. So now I pointer is what? I pointer is 3 now. Fine. Now again we are going to check whether s of f minus 1. F is here, minus 1 is 0, is equal to s of I. Yes, it is a, and that's also a. So what should I do? I should move, right? So if I move, it will be 0, and if I increment I, it will be what? 4. Yes, just move it. Here is I, and this will be moved where? Here, here. Yes, understand? Now again, just see here. F is already 0, so there is no previous element. Here is C, right? Here is C. So this condition is failed, right? This condition is failed. So where should I go? We should go to this condition. So what this condition says? It says S of F is equal to S of I. So the C should be replaced here. So replace it by C. And move this F here again. This F here again. Now understand why we are putting this condition. We are just updating that value here. Okay. Now this pointer is also moving towards right side. Okay, incremented by 1. Now a is equal to c, because f minus 1, right? F is here. F is updated to 1, and here it is updated to 5. Yes. Now 0. So 0 is c, and it is a. A is not equal to c, right? So we can make this b as a and move this f pointer here. Move this f pointer here, and it will move to 6. Now it will terminate. This loop get terminated. Now see here, this is my answer, right? This is my answer. Here is f. Here is f. F is what? 2. So the string with length 2 is my answer, right? So what is my answer? It is CA. It is efficient, right? It is efficient. We are just changing inside the string. So what is my time complexity? I can say my time complexity is O of n. And what is my space complexity? It is O of what? 1. Why? Because we are changing inside this string, right? So this is my best time and best space complexity. Let us see this code so that it will be more clear. Okay, just come up with me. First we are going to see the stack code. Okay, see here, this is not a stack code. Yes, no, this is stack code. Just implement a stack, then for I and s, then if stack and the stack of -1 is equal to I. If the stack element, the stack top, and the current element is equal, then we want to pop this stack top, right? That's what I have done here. Else I want to append that current element to the stack. Then I will join that, and then just return that stack. Okay, it means just I am taking one by one element in the stack and joining them and returning it. It means, like, if you don't know this, just come up with me. I am stack, and then maybe result plus is equal to I. Initially results will be what? Results will be empty string, right? So results will be empty string. Now Also, the one by one characters are appended, sorry, concatenated. Now we want to return what? Sorry, return result. Let me run it and check it whether it runs successfully. Yes, it runs successfully. So let me submit it. Yes, perfect. It ran successfully, right? Now let us go for what? That optimal approach. Okay. See here, this is the optimal approach. First of all, int I comma f is equal to 0. Yes, yes. Now we are iterating I from one by one in each step. And if I is greater than 0 and f is greater than 0, we don't want to mention this I is greater than 0, but still I have mentioned. Okay. If we don't mention here, it also correct. Okay. If then we want to check whether s of I is equal to s of f minus 1. If it is so, I want to do what? F minus 1, right? I have told there, right? See here, I have told here, right? If this is not, if this is true, we want to shift this f towards the left side one step. Okay. Now, else we want to do s of f is equal to s of I, then f plus plus. This is the two-pointer approach. One pointer is going one way, and another pointer is just altering, shifting, so that it can hold the value from the I. Okay, the f pointer hold the value from I. So this is a two-pointer approach. Okay. Then finally I have declared a string res. Then I'm just concatenating each and every characters, then resulting the returning the result, right? Let me submit it. Yes, it is submitted successfully. So this is the more important approach you have to know. Okay. This approach will be followed in upcoming 3 videos. Okay, just observe this approach, then you can replicate in those 3 videos by yourself. Okay, thank you.